Hello and welcome back to the Common Lisp video series where this journey we're going on here. First and foremost, I really just want to thank every single one of you that viewed my last video. I didn't realize how popular it would be. It has been the most popular video I've made in a while. I know it's not got the most views in the world, but it's certainly got way more views for being only a week old than many other of my videos. So just appreciate you liking, sharing that, and forking or starring my repos on GitHub. Genuinely massive thank you to everyone that has engaged in that. I thought it would be a rather self-indulgent video, because I found it personally fascinating. But again, thank you to every single one of you that has supported my channel. I really do appreciate that. And by way of a thank you, I'm going to dedicate the next, certainly one video, maybe two, to addressing a topic that I was asked to before I started the functional programming series. So today, and maybe next week, we're going to look at packages and projects in Common Lisp, and they're kind of all tangled up amongst one another. So to try and unpick it, we're going to have a look at packages first, and if there's time in this video, we'll look at how you build projects from them, because I've already built a project and you've seen me building projects before from a template. But we need to have a look and make sure that we understand kind of the moving parts of what's going on. So we'll start with packages because they're part of the hyperspec, and from there we'll look at asdf and quicklisp. So if you have not got asdf installed, please install it. If you've not got quicklisp installed, please install it. My setup video showed you how to set up Spacemacs with SBCL and installing quicklisp, so that should be everything you need. So if you have not watched that video and you've not set up your editing environment, you probably won't be able to follow this video, but if you have, you should. Now, I've already set up a package, but I'll show you how you can do that. Let's see. If you've got quicklisp, you can use the QL package and use the quick load function. And after we've gone through the contents of this video, what this line is doing is actually going to make a hell of a lot more sense. So we're going to load the QL project. So we're going to evaluate that. And this has just done something. It's using asdf to load the CL project behind the scenes. If you have not downloaded CL project before, quicklisp will go away and download that in dependencies, just like npm or just like pip. We're not going to go into how it's done that yet, just that it has. But now that we've loaded it, it's called behind the scenes a function asdf load system, and it's loaded the CL project for us, which allows us to take advantage of it. And that has made, that's exported a make project function. So now that we've done that, we can evaluate this, and we can see down here that this has created a project structure for us with some files in it. I'm already using the folder packages. So I was just creating packages 2 here so you could see what I'd already done. But let's get rid of those. And if I show you what I've got open, you can see that I've got my packages files here. And it created a packages directory with the source, a packages asdf file, a tests main.lisp, and a few other things. But we're just going to stick to this file for now. So what we can do is we can, I'm going to reload the interpreter. So we're starting completely fresh. There we go, we've got nothing here. So packages. If you want to find out what package you're in, there's a special variable called star package star with earmuffs there, so we can find out that we're in the Common Lisp user package. In fact, that's what this thing is here. And we can load a new system, and systems are made up of packages, into our environment here with the asdf package, and we can say load system, and we'll just say package, and that has gone away, compiled and built and loaded into our environment of the packages package. And in fact we can switch into it by saying in package packages, and that has switched us into the packages package. And if we want to switch back out, we can say in package CL user, and that takes us back into the Common Lisp user package. Now you might legitimately question why we just did that. So let's create a function in our package. We'll call it say hi, and we'll not do any code that we haven't already seen before, because we're trying to understand packages. We don't need to introduce anything new here. There we go. We have our say hi function. And again, let's make sure that I'm keeping everything clean. I'm just going to restart the environment just so you know that there's no magic going on. We're just going to load that system again. There we go. We've got our packages folder loaded, and you can see that this has now been added because it's processing the say hi function. If we scroll up, we can see that that wasn't the case last time this got built, and that's fine. So we've got this here. Now, because we have our packages package, we might say there we go. We're just going to call the say hi function from packages. It's not going to work. The symbol say hi is not external in the packages package. So if we abort that, this is where we could do the in package and say packages, and then we could say hi, and in fact it's popping up there, and we can print that out. So that's kind of cool. If we switch into a package, we can use the symbols. But that's not how we write code. We certainly, if we're building upon libraries and systems and packages that either ourselves or a third party have made, it's not exactly practical to be switching in and out of packages just to use stuff. So again, I'm just going to restart the interpreter. What we can do is we have our package here. We can actually say export, and we're going to export the say hi symbol. There we go. And if we load the system now with asdf load system, say packages, we can now say packages, and it's popped up now. It's discovered that this is external to our system, our package. Sorry, my nomenclature is all over the place. Our package, our system is composed of packages. Our packages are made up of symbols that we can choose to export or not as we want. So we can now get at this say hi symbol. And this is all good and well. Let's say we have a greeting function, and it takes a name, and it just simply returns format nil hi name. And all we're going to do with our say hi function is we are going to do this greeting name. Yep, that all looks good. So again, I'm just going to recompile this all, restart everything, so you know there's nothing left over. You know we're in a clean environment. I don't normally do this. I don't restart my interpreter quite so frequently, but because we're moving in and out of packages, I want you to know that we're starting completely clean and there's no magic left over. So we've loaded this and it's compiled that greeting function we can see here. So if we say packages, say hi, we can see here, we know that if I say greeting and pass in a name, because that is not made external, we're going to get an error. That's exactly what we want. But packages, functions and symbols and whatever that are defined inside a package that are exported can still take advantage of of functions and symbols that are not exported. So say hi has access to greeting, but stuff outside of the package does not have access to greeting. So that's pretty cool. That's a way of namespacing our stuff. But let's say we have another file, and I've created another file here that defines a package called packages.stuff. Not exactly the most inventive name, but oh well. Now if I define a function, actually, you know what I'm going to do? I'm going to copy that greeting over to the stuff. And all I can think of now is the movie The Stuff, about the killer yogurt. But never mind. So we've got our greeting here. And if we restart our interpreter, you can see that that picked up the .stuff. It's found that there is another sort of sub-package of our main package. So we get a few warnings here. It's saying that greeting is undefined in packages. So we can, try and access that. So we know that this function now exists in packages.stuff. So let's say, packages.stuff, and we do have to prefix it with a colon there. So let's restart that, and we will load the system. And we've got a problem here. So we still get an error. The symbol greeting is not external to packages.stuff. Well, we've seen this before, so let's abort that. And what we need to do is switch to this, and we need to export it. There we go. So now we've restarted this. We're going to reload the system. So this has now worked. We've got no errors. It's gone away and it's compiled this stuff.lisp first. And I do need to jump very briefly into this ASD file. I'm not going to explain too much about what's going on, but we define a system, and this is why I'm trying to get my nomenclature correct, that we define systems, and systems are made up of packages and whatnot. When we define a system, we have this thing called components, which is top level components, and then we define a module called source, and modules are also made up of components, and components can be made up of files. And it just so happens that I specify stuff first and then the main file, because we're going to put items and symbols and stuff that are going to be the main is going to depend on. So we want to compile the stuff file first and then the main file. So the order here matters. And again, we're not going to get into too much about what this is, but there's this packages ASD file, and it's just the name of the system. So when we build a system, it's called packages, and by default it creates a named package of the same system, and we just define what order files get compiled. So that's all that is, and that's why we're seeing that stuff got compiled and then main got compiled, This isn't some magic stuff that happens behind the scenes automatically. This is something that I've specified in this ASD file. But nevertheless, now that we've discussed that, we can say packages, say hi. There we go. And that has worked because we moved the greeting function into the stuff file, into the stuff package, and we call that from inside of the main package. So if we jump back here, we export our function here, and we're doing this packages stuff thing here. Now, when I discussed the packages, I said that we need to use the Common Lisp symbols here. This is what this use thing is for. So when we create our own package, if we don't use the Common Lisp package, we don't get any of the symbols that exist in the Common Lisp package, which is basically the entire language. So if we define a package without using Common Lisp, we basically have access to nothing. So it's very limiting if we don't do that. But the idea is, if we're defining our own systems, we can then use those systems. So this doesn't look very nice. It's kind of verbose. And we only really have one function in the packages.stuff. So what we can do is we can say use CL, use packages .stuff, and then we can get rid of this. And again, I'm just going to restart the REPL. And there we go. So we've loaded that now. If I say packages, say hi, it still works. And we've got this clean thing here. We can see that we're using the packages.stuff file. However, where is it? There we go. Let's say we had a lot of symbols in a package and we didn't want to use them all, because it's not generally the best thing to, you know, import every single symbol from a package. You might have your own symbols that you're masking or something like that. So we could use this use CL packages.stuff, and that will import every symbol. And you can see that if I do this. So if I delete that and type greeting, I could say greeting 2. Say packages there. Oh yeah, of course I do need to export them. That would help, of course. There we go. So let's save that. Let's delete that. So we've got greeting 2. And I'm going to restart the interpreter. Let's say greeting 4 there. Now let's load the system. There we go. And if we say asdf packages, say hi. There we go. It still works, even though we probably only want greeting rather than greeting 4, but we do still have access to all of these things. So instead of using the use, let's say we can get rid of that. In addition to exporting things, we can say import from. We can say package.stuff. We can say greeting. Now again, restarting the REPL just so we're clear. There we go, that's worked. So if we say packages, say hi, and we pass in my name, that works. Now if we say greeting 2, and again, I know it's frustrating and I know I'm doing this over and over again, but I do want to make sure that we are running very, very clean every time. There's nothing left over. So we get a warning here, undefined function packages greeting 2. So if I try to do packages say hi, we get an error. So it says that it's not defined, it doesn't have access to it. So let's abort that, put that back. And if we load it, there we go. And if we say packages, say hi, and pass in the name, it works as ever it did, or it should do. It would do if I'd actually saved the file. That would definitely help. So let's try that again. There we go. So that's worked. So even though we're exporting functions here in the stuff file, we can either choose to use all of the symbols exported by a package by using these use keywords, or we can export individual things. We say import from packages.stuff greeting, and the way this works is we could also say greeting 2. At least I think that's how it works. Let's try it. Yeah, there we go. So you can import from a package and then you just give it a list of things that you want to import. And if you want to import from another package, you just put another import from line. So that's imports, we've got exports, and that's what all this stuff is for here. So I appreciate that that is kind of a very quick whirlwind tour of what packages are doing, and this is how we can utilize symbols inside packages without jumping in and out of them all the time. Because when your interpreter starts up, it starts up in the CL user package. And when we evaluate things, even if we've got this code here, if we like evaluate this normally, we now have Common Lisp user say hi. That should have worked. What went wrong there? Undefined function common user say hi. Redefined packages say hi defun. I must have figured out what's going on there. But let's say defun. Go. If we save that, scroll down a wee bit just so we can see what's going on. There we go. I've evaluated this now. If I type boo with my name, that is very interesting. Does that mean what I think it means? It must be evaluating it in the context of the package. So let's actually switch into the package. Yeah, there we go. So when we write a function and evaluate it while we're using packages, sometimes when you do ADSF load system, it will load stuff from a package. So let's just restart everything, and from scratch, if I do this, yeah, it works. So normally when you're using the editor and the interpreter here, it's unusual for you to be using or I certainly have found it unusual to be using ADSF and loading stuff here. Normally if I'm prototyping something, I just write functions, evaluate them, test them. It's only when I come to releasing something on GitHub that I sort of package it all up and then make sure that everything's all connected and doing what it should be doing, just so people can consume my code that way, really. But when I am developing things, I just write functions, evaluate them. You've seen how I work in previous videos where I just get on with it, you know, evaluating stuff in line. But to show you something that I had been working on, I've created this other thing that I released, and this is my C format package that I tweeted about last week. It's just one function, but I did split up the logic here, so it's just this one function, but there's lots of things that could be added to. So we've got colors, we've got all of these, and I imagine, as I understand things better, it can be extended, and the same here is true of modifiers. You know, I've only got 5 so far, but as I begin to understand the spec better, I just wanted to put things here. But what that means is that when I'm actually using it, I can, you know, in here I could have used the colors and modifiers. I've chosen not to, just so that it's abundantly clear where things are coming from, because if I had just used colors, you'd see color none. Same with modifiers, it would be none. In fact, I'd have a problem here, because if I have two things called none, we'd have a name collision here. So another good reason of using these packages is that you can have the same symbol appearing in different packages, and the value could be the same, the value could be different, but semantically these have different meanings. So this is the colored none, and this is the modification none. So it does allow us to you know, split things up and have the same name in different packages and not get mixed up. So yeah, that's just an actual example of something I released here, and you can see how I've used packages to my advantage here. So I hope that has been enlightening. We'll get into asdf and quicklisp next week, but I just wanted to break down what packages are, what these use director and export and import from things are all for, and why we have this in package, and drill down into what the language provides, so then we can have a look at what the tooling around these things has become, and we can look at how you would build a package from scratch if you weren't using this CL project templating thing that I use, but that is another thing for next week. So please enjoy your weekend. If you're in the UK, enjoy the bank holiday weekend. Not that we can particularly do much in 2020, but you know, Monday off in England. Not so sure about Scotland, Ireland and Wales. I think Scotland's got... Never mind, I don't live in Scotland anymore. But hey, take care, enjoy yourselves, and I will see you in the next video.